field backward pass example. We have propagated gradients through the last 3 nodes. Now let's continue backward through the rest of the graph and compute the gradients for every parameter. The +1 node computes f7 equals f6 plus 1. The upstream gradient is 0.9975. The local gradient for an addition is simply 1. So the downstream gradient is 0.9975 times 1, which is 0.975. dl by df6 equals 99975. The exponential node computes f6 equals e to the f5. The upstream gradient is 9975. The local gradient of e to the f5 with respect to f5 is just e to the f5 itself, which is f6. We computed f6 as 0.0247. So multiply 0.9975 times 0.0247 equals 0.0247. dl by df5 equals 0.0247. The negate node computes f5 equals f4 times -1. Upstream gradient is 0.0247. Local gradient is -1. Our downstream 0.0247 times -1 equals -0.0247. So dl by df4 equals -0.0247. The addition node computes f4 equals f3 plus theta 0. This node has 2 inputs. For an addition node, the local gradient with respect to each input is 1. So dl by df3 equals -0.00247 times 1, which is -0.0247. And dl by d theta 0 also equals -0.0247. We have our first parameter gradient. Now the 2 multiplication nodes at the start, f1 equals theta 1 times x1. The upstream gradient flowing in is -0.0247. For a product at times b, the local gradient with respect to a is b and with respect to b is a. So dl by d theta 1 equals -0.0247 times x1, which is -0.0247 times 1, giving -0.0247. Similarly, f2 equals theta 2 times x2. dl by d theta 2 equals -0.0247 times x2, which is -0.0247 times 2, giving -0.049. Let's collect all the parameter gradients. dl by d theta 0 equals -0.0247. dl by d theta 1 equals -0.0247. dl by d theta 2 equals -0.049. All 3 are negative. This tells gradient descent to increase all parameters, which makes sense because the model is already quite confident and the loss is small. The key insight is efficiency. With finite differences, we would need 3 separate forward passes, 1 per parameter. With backpropagation, we computed all 3 gradients in a single backward pass, reusing the stored forward pass values. For a network with millions of parameters, that's the difference between impossible and practical. This is why backpropagation is the workhorse of deep learning.